Hello and good day everyone. My name is Noor Afaf and I would like to present a paper titled MMT Nanoclay in Smart Coatings for Corrosion Protection of Metal Alloy, a brief review. For the introduction, as reported in 2017, the annually loss in economic section due to corrosion in metals of the gross domestic product turns out to be around at 3 to 4% globally. Due to corrosion, many industries required corrosion protection to overcome this issue. To achieve this, many industrialists and academicians have devoted themselves to coming up with various excellent corrosion protection strategies. Corrosion can be avoided to some extent or mitigated by using any corrosion-resistant materials, proper material design, cathodic protection, corrosion inhibitor, and also coatings. Among all these strategies, coatings are extremely famous and widely applied. However, they can only offer excellent protection if they contain excellent additive materials and are very in-depth in application. One of the materials recently used in coatings for corrosion protection of metal alloy are MMT nanoclay. MMT nanoclay is one of the most commonly used material in various industries, known to its excellent biocompatibility and biodegradability with good mechanical properties. For the application of MMT for corrosion protection, Sun et al. Used 2-fluoroaniline polymerization MMT and cerium on carbon steel for corrosion protection. The smart coatings show some properties which are UV absorber, antioxidizer, anti-corrosion, good dispersibility, and hydrophobicity. This smart coating shows impedance value in IES corrosion measurement higher than other coating samples at above 10 to the power of 11 ohms centimeter squared, which showed that the film coating prevented further corrosion of carbon steel. Moore et al. Used cerium, sodium, and MMT as the additives on Q235 steel. Their coatings show some properties which are water resistance, dispersion stability, and also can protect from corrosion. Their result shows that coating with MMT and cerium has highest impedance value in EIS measurement. Mohammadi et al. Used cerium and MMT on CK10 mild steel. Their coating shows anti-corrosion properties. Their results show the best angle reduced to 70 degrees after 40 days of immersion and can confirm better corrosion protection than pure epoxy coating. Kumar et al. Used MMT on copper alloy and their coating showed anti-corrosion protection properties. The largest size of Nike's plot was observed for EPMC 5% MMT clay coated copper alloy. And lastly, Hasi Sorkabi used MMT on AZ91. Their coating shows hydrophobic and anti-corrosion properties. The results show that porosity and cracks become lower in results. As many of the advantages of MMT, there are also some drawbacks of MMT. Lee et al. In 2021 mentioned that MMT plays a role of a physical barrier and a container. However, the modified MMT had shown a more disordered structure and fewer stacked layers. The results showed the combination of tannic acid, cerium, and MMT did improve the long-term performance of the corrosion protection, and it was attributed to the addition of tannic acid and cerium that enhanced the physical barrier properties instead of MMT. Sun et al. In 2023 mentioned that when MMT is incorporated with polymer, they tend to get agglomerate and this is bad for corrosion protection. Hence, they added cerium to counter the drawbacks of the MMT since MMT has mechanical properties that can further improve the coating layers. In conclusion, this paper summarizes all the properties and applications of MMT nanoclay in smart coatings technology for corrosion protection. The mechanical properties of MMT in smart coatings are excellent and most coatings can even self-heal without affecting the coating's mechanical properties due to the MMT addition. These advantages make MMT one of the excellent smart materials for corrosion protection. However, there are claims stating that MMT nanoclay is an independent platelet, hence it would not interfere with the self-healing mechanism. MMT also claims to tend to agglomerate in polymer and need to be dependent on other additives to make the polymer coating work. With these many claims and statements, further research on the implementation of MMT in smart coating needs to be done to gain more knowledge on the potential and also drawbacks of the MMT nanoclay so the industry will implement them in the real world industry. Thank you.